Have you ever thought saving the world by reaching net zero for your wastewater treatment plant, or at least reduce the greenhouse gas emission? Allow me to introduce KarbonHéjo, your solution to achieve net zero, a project planned by Amreta team. This project is planned by Hafiz, Hasna, Aufa, and Anggit. We participate in the fourth challenge statement, kickstarting water's race to net zero for the tertiary tracks. At the moment, the major water corporations in the state of Victoria have pledged an emissions reductions target of net zero in 2030 to fulfill the aim of the Paris Agreement. Although Greater Western Water, operator of the alternate treatment plant, is also involved in the agreement, the alternate treatment plant itself hasn't yet reached net zero. The plant still emits greenhouse gas emissions. Based on the Greater Western Water Annual Report, the largest total emissions come from sewage collection, treatment, and recycling, which emit more than 10,000 tons carbon dioxide equivalent. If this condition goes on without amendment, the Earth will become warmer to 4.8 Celsius degree by the 22nd century. Here is the picture of alternate treatment plant, with each units written in each step. In here, we map the units in the wastewater treatment plant with a process flow diagram to identify the uses of electricity and detect units that potentially emit greenhouse gases. To clarify the analysis, we categorize it into direct and indirect emissions. There are three process units that can potentially emit greenhouse gas directly, which are IDA reactors, aerobic digesters, and truck, which emits carbon dioxide, nitrous oxide, and methane. For the indirect emissions, we identify the electricity content from each process and estimate the emissions using the data given. 9 hotspots are divided into 3 categories based on the process inside the units: physical, biological, and chemical. Each category has their own input and output. Greenhouse gas emission and electricity usage are marked with a red and green arrows respectively because it is the source of direct and indirect emission. Then the solution needed for each category are defined based on the process flow. Based on each category, we formulate the solutions for each input, process, and output phase. This method allows us to choose the right solution for achieving net zero emissions and alternate treatment plant. We propose 3 main solutions to help Altona reach net zero, consisting of grass well, high-rate algae pond, and efficiency improvement. Grass well is used to reduce wastewater inflow to the treatment plant, thus also reduce the influent to the process units of the plant. Algae pond is used to reduce primary treated influent to the following process units while preventing or reducing the release of greenhouse gases to the atmosphere. Aside from those 2 solutions, we also propose an efficiency improvement of some units in the treatment plant by increasing its process and energy efficiency to keep a sustainable and integrated wastewater treatment flow. The first proposed solution is to build grass swale along the road across the catchment area. Grass swale is a stable turf, parabolic, or trapezoidal channel used to convey stormwater runoff, which do not rely on the permeability of the soil as a pollutant removal mechanism. Considering the ATP catchment area characteristic, grass swale are feasible to be built in Altona catchment area. Here you can see the picture of typical grass swale cross-section detail. Applying this to the catchment area could give us some benefits, including reducing the peak runoff volumes, reducing electricity consumption, and also reducing direct and indirect greenhouse gas emission from the plant. It is also considered as a green infrastructure and provides health and aesthetical benefits. For the second solution, we recommend Altona treatment plant to install a high-rate algae pond to sequester carbon dioxide in offsetting carbon goals. This technology can improve the energy efficiency, maximize organic waste degradation, and inactivate pathogens in the wastewater. It will eliminate sludge disposal, produce little odor, and is capable of providing a higher degree of nutrient removal and disinfection that will minimize the use of UV disinfection unit. The system consists of 4 main unit processes: algae pond, algae settling pond, maturation pond, and rock filter. For the placement, we suggest that the system to be installed after the step screen and grid vortex unit. Hence, it will reduce the workload of the wastewater treatment unit and increasing its energy efficiency. Also, with an inflow of almost 3,500 cubic meter per day, the system can produce more than 7,600 tons of fertilizer per day, or equivalent to more than $15,000. Last, we propose 5 solutions for process that occurs in alternate treatment plant. The solutions are developing and implementing effective operational strategies and inlet pumps, using dynamic aeration system and make modification of HRT and SRT in IDA reactors, retrofit UV disinfection with UV dose spacing system, and adding turbocharger on reverse osmosis process. Most of the solution has been applied to many other plants around the world, and it is very possible to implement all these solutions in Altona treatment plant. This is the summary of the total greenhouse gas emissions reduction estimation from all the proposed solutions. Here are the economical costs and benefit of the implementation of the proposed solution. The costs are mainly consisted of capital expenditure and operational expenditure, while the savings are from the reduction of electricity consumption and byproduct sale from the algae. Altona treatment plant is one of Greater Western Water that aims to achieve net zero emission by 2030, yet it hasn't reached the goal yet. There were 9 hotspots identified based on emission scope, which is direct and indirect emission. After breaking down the problems, we proposed 3 solutions to tackle the greenhouse gas emission: grass well, high-rate algae pond, and efficiency improvement. The impacts of the solution are significant to reducing greenhouse gas emission, that are carbon saving, reducing electricity consumption, minimizing systems workload, and integrating green infrastructure. So, are you ready to be the change needed by the world? Thank you.